So for the first time we've talked about this. This is tolerance. And so a couple examples for us to get us started here. And this first one says your friend has $50 in the bank account, give or take $15. Okay, so what's the most and least amount of money she could have? Okay, so how do we represent that? Well, she could have $50 exactly, right? She could have a little bit more, a little bit less. So the way I thought about this was she could have $50 plus or minus 15, right? Okay, that's what she could have. She could have $65, she could have $35, somewhere in between, right? So how would we represent this with an inequality? Okay, this is the question. Or how would I represent this with absolute value specifically? Okay, so here's what I was kind of thinking. All right, if I let x represent the amount of money she has, it really is this formula here, right? She have a little bit more than 50, a little bit less than 50. I could move this 50 over here out of the way, okay, so that 15 is kind of highlighted. 15 represents that give or take amount, right? That amount that she might have a little bit more or less of, right? So I'm keeping the plus or minus on there for now, okay? But think about what we do when we do absolute value, right? Absolute value is the positive case or the negative case when we split it apart. So before we split it apart, before we make that branch off, what is wrapped around the x minus 50? What's usually around the x minus 50 when you're talking about absolute value? The bars, yeah, the bars, right? And so we'll bring back the bars now, okay? The plus or minus, when we split it apart, kind of takes the bars off, right? So we're almost like we're going backwards here, okay? So if I create this like this, and I have this 15 over here, I can take the plus or minus off now, okay? Because I took care of it with the bars, right? It's almost like I'm going backwards, okay? Like I split it off this way now, going up, okay? However, there's one other change I want to make, right? I don't want that give or take amount to be more than $15, right? She doesn't have $70 in her bank account, right? 15 is like the max, okay? So I'm going to use a little less than symbol here, and we'll put some equality on it because it might be exactly $15, right? It doesn't have to be exactly 15, but it could be, okay? So we backed into an absolute value inequality, okay? But I want you to kind of parallel that with the next example too, all right? So there's another one down there, and we'll see how that would work as well, all right? It says a baseball, so a Major League Baseball weighs 5.125 ounces. However, it can have a little bit of a tolerance, right? So there's a little bit of wiggle room. It doesn't have to be exactly that number, right? It can weigh 0.0125 ounces more or less in the other direction, okay? So what's the least or the greatest amount the ball can weigh? Well, do you guys know what they rub a baseball with before they use it? You ever heard this? Like before a baseball is used in a game, do you know what's rubbed with? Mud, actually. Yeah, it's like a special mud. Peanut butter would be interesting, yes. It's actually this very special river mud that's from like Pennsylvania or something. You got to fact check me on that. I think I'm in the right area though, right? But it's really weird. So there's the difference in the weight, right? There's the fluctuation in the weight, okay? So how could we represent this, right? The ball could be, we want it to be 5.125 ounces, but it's got this wiggle room, right? It's got this little bit of extra that it could be above or below that, just depending on the manufacturing of the ball, okay? So if I kind of follow that same pattern that we did a minute ago, I can move the 5.125, the thing that I want it to be, out of the way. So I would subtract it to the other side, and I could set it equal to what we're calling this tolerance, okay? This amount that it could be more or less of, all right? But to turn it into an absolute value problem, I'm just going to get rid of the plus or minus and bring back the bars, right? Kind of going backwards in our process. So it looks like this, okay? But remember, I don't want that to be more than that amount, okay? So I'm going to use a less than symbol there and put that same number back down, okay? So what are the acceptable weights then, right? Well, if I add this amount to what we're calling like the ideal weight, the thing we really want it to be, right? It's about 5.1375, okay? If I subtract it off of there, same idea, but subtracting it, I would have about 5.1, let's see, about 5.125. I had to cheat a little bit on that one, but that's where we'd be, okay? And because it's got the less than or equal to symbol, okay, I'm okay including those numbers, right? I would bracket that and just put a comma between them. So this is a situation like kind of like we talked about the other day, we have a less than symbol in the problem, so we know the answer is going to be sandwiched between two numbers. Okay, so think about a number line, and you would be shading the middle section there on the number line. Okay, same idea. Okay, and so this form that we're setting up here, if you notice, the inequalities look very similar. This is what a tolerance problem is going to look like. Okay, so let's first of all define a tolerance problem, and then I'm going to give you kind of one way to look at it. Okay, as far as a formula goes. So tolerance is the amount that a value, like the number we can have, can change and still be acceptable. Okay, so let's kind of write that down. Fluctuate would be a good word too, like how much can it wiggle up or down, fluctuate up or down. Okay, so the amount of value can change and still be acceptable is what we're looking for. So we'll go through a couple different ideas today, but the reason it's kind of related to what we're doing, okay, is because we can use absolute value to represent this. Okay, so the form we've had, right, are that the bars are less than or equal to some number over here. We're going to call this number the tolerance. Okay, the amount it can fluctuate up or down. And then inside the bars goes x minus something, right? And we're going to call this number like the ideal number, the thing that we really want. Okay? And the cool part about it is they all fit this form. Okay, so they all have less than symbols. They all have x minus inside the number. Okay, the reason for the minus sign is because our ideal number should always be positive, right? Like we're talking about real life things, weights and distances and lengths and volumes and things like that. Okay. So it's gonna, when we brought it over to the left side, like we did in our first couple examples, right, it's gonna be subtracted to that side. So that minus sign is always there. The tolerance is just a number that's in the problem, okay, the amount that it can fluctuate. Okay, and so I'm gonna give you some different situations today and on the homework, and you're gonna be able to try to write these equations or the solutions, right? Like this is a solution right here that we put in the brackets, okay? And so you wanna write some sort of solution, sometimes in interval notation, okay? All right, so everybody got their tolerance formula? All right, here we go. So another example for us. The correct torque setting for the lug bolts on a race car, okay, is 85 foot-pounds. So if you ever torque down a lug nut on a car, okay, they have a specific like torque that you can torque them down to, but you can be a little bit above or below that. What? Torque. So anyway. Let's write an absolute value inequality that expresses this, all right? So it's really simple, okay? 85 represents the ideal number we want. 3 is the tolerance. It can be 88, it can be 82, it can be 84, okay? But it's got to be within this range, so this acceptable range. And so our inequality looks like this. X minus the ideal in the bars is less than or equal to 3. So what's the lowest the torque could be on the lug nuts? Is torque a thing? I don't know.
Torque?
Well, I don't know why you guys are laughing.
Mr. Professor, I do not know what torque means.
All right, I'll look it up later.
Oh, don't look it up. Don't look it up.
Wait, twerk or torque? What are you saying?
No, it's supposed to keep it in.
Oh, it did? Oh, all right, my bad. Sorry, third hour. This is getting weird. So, the least it could be is 82. What's the highest it could be? 88, right? And so we would wrap those up in brackets with a comma between them, like you're doing the interval inside the middle, okay? That's between the two values, okay? Very nice. All right, when you're ready, flip it to the back side. See if you can answer example 2 with your group. Figure out which ones are acceptable and which ones are not. All right, so which ones of these are acceptable? A works. Does it? Does it work? Yeah. A works, right? Because it's within this wiggle room, right? So the wiggle room is 0.05 inches. So the low could be 45, the high could be 55, right? Which other one works? C's in there, right? C works. This one's too low. The other one's too high, right? So the reason I kind of threw this example in is the manufacturing. Okay, if you go into like I would say like industrial engineering, mechanical engineering, if you work at a factory, parts, anything like that, anything related to building something, there's always going to be a tolerance. Nothing is perfect, okay? So like even when they spit out things on an assembly line, right, there's always defects. There's always this fluctuation between part sizes and things like that, okay? So there's a tolerance. There's an acceptable range of things that you can make these parts for. So what are some other places in real life that you guys can think of maybe where you see this? Any thoughts? I have a couple ideas, but I'll see if you guys come up with it. Where? Food is a great example. Yeah. What'd you say, Dylan? Do I need to write it down? No, don't worry about it. Okay. Food's a great example. What else? Anybody got another example? Oh yeah, tire pressure. Nobody's ever said that. That's like a really good one. My truck says 35, right? So 35 psi is what you're supposed to fill my truck tires up to. However, if it's up to 40 or if it's down to 30, it's not a big deal. Okay, you can go. There's definitely a range that it's okay. Does anybody ever have those lights blink on their car that's like, hey, your pressure's too low? Yeah. So you got out of the acceptable range, right?
I don't have a car.
No, that's okay. Yeah. But mine are always blinking, and they happen in the winter too, by the way, because the cold air reduces the pressure. So. What else? Anybody got another example? I have a good sports example. Think of a sport that uses ranges of numbers, okay, to classify people. What am I thinking of? Wrestling or boxing. Okay. Anybody wrestle or box in here or anything like that? There's like you could be let's say a weight class is like ideally you're 155 or something like that, right? But you can be a little bit plus or minus that to be in the weight class. Does that make sense? You guys know what I'm talking about? Okay, so I was thinking something along those lines, like weight classes for different sports, right? All right, so you guys have a couple examples here. Let's look at the last part of this here and finish it up, okay? All right, so example 3 here. The thickness of the mats used in gymnastics events are supposed to be between 7.5 and 8.25 inches, okay? Inclusive means they're included. So if I wrote those down, I would write it like this: 7.5 up to 8.25 with brackets on it. Okay. So it says write an absolute value inequality describing the acceptable mat thicknesses. Okay. What's different about this problem though? Why is this different than what I've already given you guys so far? Yeah. We started with the low and the high, right? The max and the min. We don't know the ideal and we don't know the tolerance, right? So how would you find an ideal number if you didn't know it? Yeah, take their averages, right? Add them together and divide by 2. So let's do that. On fire today. So, ideal, okay? To calculate an ideal if you don't know it, we just average the 2 values. All right, so add them together, divide by 2. If I do that, let's see, we get about 7.875. I'll save you a little trouble here. Okay. So that gives us the ideal that we need to put inside the bars. What about the tolerance then? How do I know how much it's fluctuated? What would I do for that? Yeah. Subtract the highest value from the average, or you could subtract the average and the low. It doesn't matter, okay? It's either one. But yeah, I like that idea. So we would take one of the extents, like one of the highest points, okay, and subtract it from that average, and you could get the tolerance, how much it can fluctuate, okay? And this is easier done when the numbers are nice and whole numbers or round numbers, right? You can probably see it easier. But for example, like this with decimals, that's the move, okay? And so our inequality would look like this: x minus the ideal number, which is 7.875, and that has to be less than or equal to 3/8, right? Why do you think the gym mats have a lower limit? Why do you think 7.5 is as low as they want to be? What happens if the mats are only like an inch thick?
And then you don't have any like.
Yeah. No cushion. They might hurt, right? What if they're too much? What if they're like huge?
Then you can't get on.
Yeah. Yeah. You ever tried to walk on? You ever tried to walk on something like that? It's like impossible because you're like sinking into it the whole time, right? Or it's just too much for the apparatus or something, right? Example 4 is similar. Let's see if we can figure this one out here without too much math. It says gorillas can weigh between 300 and 500 pounds, okay? So ideally, what would they be, guys? 400, okay? This would be our ideal here, right? Right in between the two numbers. How much can it fluctuate from the ideal? Yeah. If 300 is the low and 500 is the high, it could fluctuate 100 pounds, right? This would represent your tolerance, okay? So some of these you can put together super quick, okay? But I want you to have two different examples to kind of see it, right? See which one, see one version with the kind of more formula version, okay? And then down here you can kind of see it, okay? So can I help clarify so far? You guys feel okay on tolerance? So down below, example 5, steel rods produced at a factory should be 10 inches in length, okay? But they can fluctuate up to 2/10 of an inch, okay? So if they're not within that range, you got to throw them out, right? Which of the following inequalities should be used to talk about the steel rod's tolerance? This, by the way, is a great question, okay? It's a good one. This is a good finals question, okay? It really makes me understand like whether or not you understood tolerance, right? It's multiple choice. It's perfect. I might just use this one, okay? So make a star in your notes. Which one works? C. C has the ideal, okay, here. Has the tolerance here. I mean, so does, is that the only one that does that? Oh, that was too easy then, I guess. What are you also looking for to make sure you know which one's the right one? What other thing should we look for? The symbol, right? The symbol should always be a what? Less than symbol, okay? So keep an eye out for that as well. And then you guys have time now to finish up homework 5.4. I'm going to open it up real quick for you, and then homework 5.3, okay? Make sure those are all completed.